So in order to calculate the turnover number, or kcat, what we need to use is our Vmax that we just determined from our Eddie Hofstade plot. So let's say we have a Vmax of 49.4 micromolar per minute. And by convention, we usually give a kcat as per second. So we just simply convert the minutes into second by dividing the number that we got for our Vmax by 60. So 49.4 divided by 60, we get 0.823 micromolar per second here. And of course, we can very easily convert that, the micromolar, into molar, just simply by dividing this number by 10 to the 6. So we divide this number by 10 to the 6, and we convert the micromolar into molar, and we get this number here. So that is the concentration change per second of the substrate. Now, what happens with our enzyme? We know that we had 21.8 microgram per milliliter, and we can easily convert that into some other units. So, for example, we can just multiply everything by, or extend the unit by factor of 1000. So if I extend the microgram by 1000 and multiply the milliliter by 1000, I get exactly the same number of 21.8, but now in milligram per liter or in nanogram per microliter. And however way we want to write it, it doesn't make any huge difference. Now, we know that we used 20 microliters of the enzyme, and therefore we know that 20 microliter goes into 1 milliliter 50 times. So if we want to figure out how much enzyme, the amount of enzyme that we actually used, we just use the stock concentration and divide it by 50, because that gives us actually the amount of enzyme that we used in our assay in the cuvette. So that's 0.436 microgram. That's the amount of enzyme that we had. And we can now convert this the grams to moles, and for example we can say mole, and if we use dimensional analysis we can say is 1 mole over 35,000 gram, that was the molecular mass, times 0.436 times 10 to the minus 6 grams, and this is this number here. We see the grams cancel out, and if we do this calculation we will get 1.2 something times 10 to the minus 11 mole that we actually had in our cuvette. And now we need to figure out what is the concentration. So concentration, we know that the concentration is given as amount of the enzyme, that's this one here, divided by the volume, and the volume was 3 milliliter, or 3 times 10 to the minus 3 liter. So if we do this calculation, we divide this number here by 3 times 10 to the minus 3, and we get a concentration of 4.15 times 10 to the minus 9 mole per liter, which of course is the same as 4.15 nanomolar. Or we can also write it as 4.15 times 10 to the minus 9 molar. Now, in order to calculate kcat, we divide the Vmax that we have used previously, so that is our Vmax here. That's the 8.23 times 10 to the minus 7 molar per second, and we divide that by our 4.15 times 10 to the minus 9 molar. That's this number that we just calculated for the enzyme, and when we do that we will get 198. What is the unit that's left? Well, the molar cancels out, and all we have left is the unit second, so this would give us 198 seconds to the minus 1. So for this particular experiment, I expected a turnover number somewhere between, let's say, 100 and 300 molecules of substrate per molecule of enzyme per second. So that was the expectation